So what are the gaps do you see between the student exemplar and the teacher exemplar?
One gap I noticed was my students did not disprove the incorrect answers. Another gap that I noticed is my students identified the key numbers in their problem, but they didn't identify the key words to indicate the operation they would use.
Why were they unable to eliminate A, B, and D as a possibility?
My students weren't able to identify a clear path to these answers. They couldn't figure out or couldn't identify how someone would arrive at 6 because they're adding 3 numbers that are clearly larger than 6. 7 was one of the key numbers, but again, they're adding more to 7, so they know it would be bigger. And then 15 could just be a simple calculation error, but it's hard for a first grader to articulate those.
Okay, how about the other problems?
The other problems were similar. This was a problem that was read aloud to them. So there weren't any key numbers or keywords to underline. So they just had to identify these numbers, listen to the instructions, and solve the problem. But again, she didn't disprove any of the other options.
Okay.
The next one, she did not underline her key numbers or keywords, but she still found the correct numbers,
So
and
the
she
gap
knew the
was
correct
in
operation.
the B and the B, I guess, because she did her analyze.
Mm-hmm. Yeah, exactly. And again, she didn't disprove these. This one was an open-ended question, so it didn't have anything to disprove, but she did underline her key numbers. The only thing that she was missing was underlining her keywords to indicate the operation.
Okay, let's look at some mid-level samples.
So this one, he identified his key numbers. I think he attempted to identify a key word. He said now. So I think his thinking was, how much do they have now? I need to add all these together. So he added them together, drew his caret, added the extra number, and arrived at the correct answer. But again, he didn't know how to disprove these because it was too hard for him to come up with, so he crossed them out to show that they were incorrect. And this one was one that was read to them, so he didn't have anything to underline, but he knew the correct operation by listening. And let's see, so his calculation, he had a calculation error here. 9 plus 3, he said it was 13.
Okay.
So then that gave him an incorrect answer at the end. Over here, he did not underline his key numbers or keywords, but he was still able to identify them and solve the problem correctly. And down here, again, he didn't underline key numbers or keywords, but he was still able to identify those and solve correctly.
Okay, let's look at a few other mediums before we go to lows.
Okay. So this student didn't underline any key numbers or keywords, but he was still able to write down the key numbers and identify the correct operation he used, and he came to the correct answer, and he crossed out the incorrect answers.
Looks like the same error here on
Yeah,
2.
exactly. 9 plus 3.
Calculation error.
Here, he did not underline key numbers or keywords, and he did not show his work, but he came up with the correct answer. So I noticed with some of my students, I have to remind them to actually draw out their work and show me, rather than just doing it in their head and counting on their fingers. I see them doing it, but when it comes to analyzing the test, I can't see their thinking. So I do have to remind them of that.
So on those 2 work samples, what would you say are the what are the two highest leverage gaps that you noticed? Commonalities on both of them.
I would say remembering to underline the key numbers and keywords, even though they were,
process.
yeah. And the other thing was just their calculation errors.
And how can you avoid or put a safeguard in place for those calculation errors?
Just reminding them to show their work and double check.
What's a way that they could, another way they can show their work other than the carrot to ensure that they added the two numbers correctly?
We've gone back this week and practiced different addition and subtraction strategies, such as drawing dots. We're starting with a number and adding dots to it, just reviewing processes like that.
So can we adjust our exemplar right now to reflect that?
So another way that I show them is starting with 7, and they add the next number to it. So then they would count 7, 8, 9, 10. So they could put 10 right here and then remember to add the 4 to it. So they could put 1, 2, 3, 4, and then count 10, 11, 12, 13, 14.
I feel like they could put plus signs here if they don't want to write out the full numbers, and they can also do dots underneath the numbers.
Okay, let's write that in. Okay.
I feel like some of these errors were pretty common between the middle range, so I'll look at some lower ones. Okay, so this student got one question correct out of 4. The first one, he boxed his key words, but he didn't box any key numbers. But he was able to write the correct numbers, but it looks like his operations, he wasn't quite sure, even though he tried to find the correct words. He was just struggling with that, and he is a low reader, so even though I read the question to him, trying to follow along and go back and find those words was challenging for him. So he calculated incorrectly because he was unsure about the operation.
Got it.
This one, the numbers are here clearly for him, so he found the numbers, and he used the correct operations, but he had a calculation error. He has his dots over here, so I see 1, 2, 3, 4, 5, 6, 2, yeah. So he has 6 for that one, 3 for that one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So he has the correct number of dots, he just counted incorrectly. And one strategy that I usually show them that I see he didn't do was crossing them out as he counts them, and he didn't do that, so it's easy for him to just miss one.
He also had that same work here for that one.
Okay.
All right, so for this one, he didn't identify any key numbers or keywords. He showed a little bit of work here. 1, 2, 3, 4, 5, 6, 7, 8, 9. He has 9 dots, 3 dots, and 5 dots. So he was able to count each of the dots and find the correct answer, but I would still like him to cross them out as he's counting so he doesn't make the same error that he did before. And down here he drew his dots again and he counted incorrectly, so again just missing that strategy.
So let's compare him with some of the other students who did not score as well.
16, 17, 18, 19. I see 19 tally marks.
Which is
I
much
think
closer.
I think he started out using this and got lost in what he was doing and just abandoned that strategy.
So what could he have done with his dots or his tally marks to eliminate some of the confusion that he did here?
He could have used the like just starting with the number, so writing the number 9 and adding 3. That way he doesn't get lost in drawing so many dots. Or he could have just drawn 9 dots here, plus 3 dots, plus 6 dots.
And then cross each one of them out as they go.
I also feel like on this one, reminding the students that if they are going to use the dot method, to put the number so that they don't make that mistake of using too many dots when they're doing the dots.
So write the full equation and then match the dots with each number in the equation. All right, let's check on one more. I see a lot of similarities between the two that you showed me. Let's check on one more.
So she circled a lot of keywords, and she found all of her key numbers, but she didn't write them down. She did draw out her dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And she circled 14, but I see 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. I see 13. So I'm wondering if she just found the number that was closest to the answer she found.
Yeah.
So that was just kind of a guess. 1, 2, 3, 4, 5, 6, 7, 8, 9. So she drew 9 dots, 3 dots, and 6 dots, and counted them up. But I would still like to see the crossing out strategy.
Nice.
Over here, she drew out her dots. I would like to see them grouped better with a plus sign in between, and then crossing them out as she counted, because she circled 14, so she had a calculation error. She circled 14 but wrote 17, so I'm a little unsure what was going on there. 1, 2, 3, 4, 5, 6, 7, 8, 16. Yeah, she has 17 dots, wrote 17, but
Looks like she tried to circle it out one.
yeah, she did, and then erased it. So. And then the very last one, she grouped the dots based on her key numbers. So she has 6, 2, and 7. So this is much clearer, but she didn't cross them out as she counted, so she missed one and wrote 14 instead of 15.
Okay, so if you grouped those kiddos in an intervention, what would give you the biggest bang for your buck?
I would go over questions like this again, reminding them to identify those key numbers and keywords, and then practice these addition strategies again.
So writing the equation and doing what? So step 1 would be your B, your box, and your analyze. Once you get to the S, the solve, what do you want to see them doing?
I would like them to write out the equation, use a caret to add 2 of the numbers together, and then utilize either a dot strategy or the number plus dots to show their work and make sure that they are calculating correctly.
Which one will be the least confusing method to teach this intervention group?
Drawing the individual dots.
Drawing the individual dots. So write the equation, draw the individual dots, cross them off as they go. Do you have? So what students need to do, they need to
write out equation. Draw dots to represent each number in the equation, and cross off dots as they count.
they're counting on. Excellent. And in general, with all of your students, what would be something that you would remind them to do each time that they were in dealing with a word problem?
I would remind them to use base every time and box all of their keywords and key numbers prior to writing out their equation.
which is
NBT2.
NBT2 right here. All right, what do students need to know and what do students need to do with NBT2?
So the standard says understand the 2 digits of a 2-digit number represent amounts of tens and ones. Understand the following as special cases. 10 can be thought of as a bundle of tens called a 10. Here's my exemplar for the upcoming quiz.
Excellent.
They need to identify the digit in the tens place. So they give them the number, they need to correctly put each digit from that number in the correct place in their place value chart. I had them drawing out models. When I got to this one, I realized that is very excessive when I was creating it. The only other way I could think of is to have them make their place value chart for each one. And that way they would identify it's 8 tens and 9 ones.
So I'm going to suggest, can I borrow your pencil? Same thing there, right? Yeah. Let me grapple with that. I'm going to suggest when they're doing the model for this for ones and tens that you do have them put 8 ones. This is also, I'm predicting, going to be a little confusing because you have the ones here, then the tens here, and you have the tens here, the ones here. So always starting with the ones. How many ones do we have? We have 8 ones. I'm going to put that over here, and I'm also going to draw my model with it. Then I have, maybe I'll put a box around my tens. How many tens do I have? I have 9 tens, and I'm going to draw 9 tens. So using both strategies in one, but really having an intentional process of how to read this and then how to transfer what they're seeing here into the place value chart with the corresponding ones and tens.
I like that. Just to remind myself.
Okay, let's talk about instructional design and let's look at your spiral and see how those match up. How is this going to build the understanding of the ones and the tens, and what will we need to supplement this?
Students will be able to use manipulatives to connect 10 blocks together to identify how many groups of 10 they have, and then all of their extra pieces will be in the ones place. So this just gives a visual representation of a place value chart showing groups of tens and ones.
Okay, so going from manipulatives to what they have to do. So let's go back to what they have to do here and make sure our instructional design that we have this accounted for.